Techdaily.ai, your source for technical information. This deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyper-converged in VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com. Today we're going deep. We're looking at the origins of the C programming language.
Yeah, it's quite a story.
It really is, and it's not just code and compilers. It ties into early operating systems, time sharing, even a bit of language history. We've looked through a lot of background to pull out the really interesting bits for you.
Absolutely. The mission really is to unpack how this fundamental tool actually came about. It's kind of surprising.
So where does this story, where does it properly kick off?
Well, you really have to go back to the early days of time sharing, specifically a massive project called Multics.
Multics, right? That was MIT, Bell Labs, GE.
Yeah.
A huge undertaking.
Exactly. The idea was ambitious, create this sort of computing utility, like one giant machine everyone could plug into and use simultaneously.
A computing utility. I like that description. And key thing about Multics, wasn't it, was the decision to not use assembly language.
That was pretty radical for the time. They wanted to use high-level languages. They tried PL1 first.
Which didn't quite pan out, as I understand it.
No, not really suitable. So then they turned to BCPL, which was developed over at Cambridge by Martin Richards.
Okay, BCPL. So the idea of using higher-level languages for system stuff was already floating around thanks to Multics.
It planted the seed, definitely. And that seed really took root over at Bell Labs.
With Ken Thompson and Dennis Ritchie.
Right. They saw what was happening with Multics, this whole concept of building system software in languages humans could actually read more easily. They were inspired.
But they weren't aiming for something as massive as Multics, were they?
No. They had a different vision, something smaller, leaner. A stripped-down time-sharing system, which, eventually became Unix.
And the goal was to build this new Unix and its tools using a high-level language from the get-go, moving away from assembly.
That was the dream, freedom from assembly language complexity.
So this leads us to the B language created by Ken Thompson. What was B all about?
Okay, so B was Thompson's attempt. He took BCPL and simplified it, made it more concise.
Simpler. But I've heard the naming was a bit terse.
Terse is one way to put it. Some might say cryptic. It wasn't the most descriptive, let's say.
Okay, so maybe not the most user-friendly names, but what were the real limitations of B, the technical hurdles?
Well, the big ones were, first, it was interpreted.
Interpreted. Meaning it ran slower than compiled code.
Generally, yes, like having a live translator instead of a finished script. And second, it wasn't a great fit for the newer hardware coming out, like the PDP-11.
Why not? What was the issue with the PDP-11?
The PDP-11 could handle data in different chunks, 8-bit bytes for characters, 16-bit words for integers, things like that. B didn't really have a good way to express those differences. It was kind of typeless in that regard.
I see. So it couldn't efficiently use the machine's ability to work with different data sizes.
Right.
It was a stepping stone, but flawed.
Exactly. A valuable experiment, but it hit a wall.
And this is where Dennis Ritchie steps in to, fix things.
Precisely. Ritchie saw the limitations of B and set out to create something richer, something that could handle those hardware specifics.
And the key innovation was?
Data types. Explicit data types. He added mechanisms to let the programmer define the size and type of data, things like char for characters, int for integers.
So the language could now directly reflect what the hardware was actually doing.
You got it. It allowed for much more efficient code because the compiler knew exactly what kind of data it was dealing with.
Makes sense. So he designs this richer language.
Yeah.
What comes next?
He writes a compiler for it. A compiler for this new language, which of course became C.
The first C compiler.
Yeah.
And then came the really ambitious part.
Oh, yeah. Rewriting Unix.
The entire operating system.
Yeah.
In this brand new language.
The whole thing. Using the C compiler he just built, apparently it took about 6 months.
Wow, 6 months. It's incredibly fast for rewriting an OS, isn't it?
It really is. Speaks volumes about C's suitability, I think. And this rewrite, this was a game changer.
How so? What were the big impacts?
2 massive things. First, readability. Because C is high level compared to assembly, the Unix source code suddenly became understandable to way more people. You didn't need to be an assembly guru anymore.
Democratized it, in a way.
Sorta, yeah. And second, maybe even bigger, portability.
The holy grail. The ability to run on different machines.
Exactly. The idea was if you write a C compiler for a new machine architecture, Boom. You can recompile UNIX, recompile your C programs, and they should just run on that new hardware.
Without massive rewrites.
With relatively little modification, yeah. It freed UNIX from being locked to the PDP-11. It could travel. That was revolutionary.
It really laid the foundation for software being independent of specific hardware, something we totally take for granted now. Okay, but there's that classic question. The C compiler is written in C. How does that work? It sounds circular.
It does, doesn't it? It's called bootstrapping. It's a gradual process.
Okay, walk me through it.
Right. So you start small. You take a tiny subset of the C language, just the absolute basics, and you manually, painstakingly translate that tiny bit of C code into the actual machine language for your target computer.
Okay, so you handcraft a mini compiler in machine code.
Exactly. A very, very rudimentary compiler. But it's enough to compile a slightly larger piece of C code, and then you use that compiler to compile an even bigger chunk of C. You keep repeating this cycle. The compiler you just built helps you build the next, more capable version.
Building itself up by its own bootstraps, literally.
Pretty much. Until eventually you have a compiler that can compile the entire C language specification, and that compiler itself is written purely in C. It's quite elegant, actually.
That is clever. A self-hosting compiler. Okay, so we have the language, the compiler, the OS rewritten. What about documenting it? The K&R book is iconic. How did that come about?
Well, the story goes that Brian Kernighan, who is deeply involved in the UNIX environment.
Right, Kernighan, the canary in K&R.
That's him. He'd recognized the need for better documentation earlier on. He actually wrote a tutorial for B first, because the official docs were more like reference manuals, not great for learning.
So he had a knack for explaining things.
Seems so. When C came along, he wrote a tutorial for that too, for the same reasons. There just wasn't good introductory material.
And that tutorial became the basis for the book.
Essentially, yes. He'd written other technical books and saw the need for a proper, comprehensive book on C. He proposed collaborating with Dennis Ritchie.
The language creator himself, the R in K&R.
The very same. And teaming up was, well, a stroke of genius. You had Kernighan's excellent tutorial style, combined with Ritchie's definitive reference manual.
The perfect combination. The how and the what.
Exactly. They put it together in 1977, and it was published early 78.
And they used Bell Labs' own tools to write it, didn't they?
Oh, yeah. Tools like EQN for math equations, TBL for tables, all homegrown stuff. The first edition actually came out before the PIC language for diagrams existed.
Using the system to document the system. I love it. Was it expected to be a bestseller?
Not exactly. The publisher's initial sales estimate was apparently quite low, something like 5,000 copies.
Seriously? 5,000?
Yeah. Needless to say, it slightly exceeded expectations, became the C book for generations.
Understatement of the century. Okay, one last bit of history. People always ask, if there's a B, was there an A?
It's the logical question, right? Well, there wasn't a direct language called A in this specific line, but there was an influence.
Oh, go on.
Steve Johnson, another Bell Labs guy, famous for creating Yak.
The compiler tool.
Yeah. He did a sabbatical up at the University of Waterloo in Canada, and while he was there, he came across a language called EH, spelled E-H.
EH, like the Canadian stereotype.
Apparently pronounced with a bit of that Canadian inflection, yes. And this EH language had some ideas that Johnson brought back, and they sort of indirectly fed into the thinking around B and C.
So not a direct ancestor, but maybe like an influential cousin?
That's a good way to put it. An influential cousin. It just shows how ideas bounce around and get synthesized.
It really does. It's never just a straight line, is it?
Rarely. Innovation's usually messier than that.
Techdaily.ai, your source for technical information. This deep dive was sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged in VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com. So wrapping this up, what does this whole C origin story mean for you, our listener?
I think it really shows how progress happens, right? Building on what came before, fixing the problems you hit along the way.
Definitely. And the importance of making things understandable, like with the book. Good documentation can make or break a technology's impact.
Absolutely. And it's just fascinating how these fundamental tools we rely on every single day often have these, well, human stories behind them, twists and turns, even a bit of humor like the EH language. Yeah, so maybe a thought to leave you with. Look at the tools you use every day. How many have their own weird, complex backstories? And maybe think about what's the B or the EH in your own field. What little experiment or overlooked idea might actually be the key to the next big C?